In our next video here, we're going to find the area of some triangles by using a new formula. What is the formula for the area of a triangle? Now, our normal formula would be area is equal to 1/2 times base times height from geometry. However, we know that the sine of C, if we go in here and find the sine of C, sine is equal to opposite over hypotenuse, so the sine of C would be h over a. So therefore, h would equal, if we were to solve this, we could flip-flop our a, or we can move our a over, so h would be a times the sine of c. So we could rewrite our formula by substitute that in for our original. We have the area of a triangle is actually equal to, now we could write it as 1/2 times b times a times the sine of c. Now most of the time these will be flip-flop and they'll write it like this. They'll do 1/2, let me clean that up a little bit, 1/2 ab times the sine of c. So we actually have now a new formula that we don't have to have the height. We can have an angle and two side lengths. This actually works for a side angle side type relationship. And we could do, this is not the only formula, we could do 1/2 times b times c times the sine of a. We could do 1/2 times a times c times sine of b. So there's actually 3 different formulas we could use here. But let's go ahead and do some examples. So here's our a value. So the area of this triangle, now careful, this stands for area. This is angle A. Area is equal to 1/2 times, we can let this be B and C, but it really doesn't matter because it's 1/2 times 16 times 11. It's the two side lengths times the sine of the included angle. So we'll type it in like this. Half of 6 will be 8. 8 times 11 is 88 times the sine of 105. Type that into your calculator and you get about 85 square feet. The next one, again, area is equal to, and now the formula is simply this. It's 1/2 times the side times the other side times the sine of the angle in between the two sides is the actual formula. That can be typed straight into our calculator and you're going to get 106.8 square inches. Number 3, now there's a problem. We don't have a side angle side relationship. However, look at the note. You need a side angle side to find the area. Use the law of sines or law of cosines first for these type of examples. So sometimes you might have an extra step with these. Now, if I use the law of sines, I've got this angle side. Now, if I use the law of sines with this one, that would tell me what this side was equal to. Now, be careful of that because I still don't have a side angle side relationship. So what I'm going to have to do, let me erase that. Let's find this third angle. 59, 76, add them together, subtract from 180, and you get 45 degrees. So now I could use that, and if I can use that to find this side, then I will have a side angle side relationship. So let's do that. That'll be the sine of 76 over 7 is equal to the sine of 45 over, we'll call it x, and that'll give me that x value. And that gives me, when you solve it, an x value of about 5.1. Now, here's your side angle side relationship. So the area of this triangle will be 1/2 times 5.1 times 7 times the sine of 59 degrees. Once you type all that in, you get an area value of 15.3, and that is in square millimeters since we're talking about area. Now, yeah, I was making sure I put the right units up there. Again, we need a side angle side. We don't have that. However, we can use law of sines or law of cosines. If this is 126, this is 22. Add them to subtract from 180, and you get a 32-degree angle. So use your law of, like I said, law of sines or law of cosines. You have the sine of 32 over 13 is equal to, I guess we can do the sine of 22 over x, and we'll use that to find this side. 13 times the sine of 22, multiply them, divide by the sine of 32, and you get about 9.19. And let me replace that right here. Now you have, again, your side angle side relationship. So the area is equal to 1/2 times 13 times 9.19 times the sine of the included angle, which is 126. Type all of that in, and you get an area of about 48.4, and that'll be in square kilometers. Number 5. Again, do the exact same thing. We need a missing side length. You can use your law of sines here. However, if you use the law of sines, it looks like it's going to give you an angle measure. So this might require a couple of steps, and let's try it. So we have the sine of 85 over 11 is equal to, let's see, we're going to be looking for this angle, which would be the sine of x over 5. To solve that, again, we're going to move the 5 up here, type all of this in, then we'll find the inverse sine, and that's going to tell me that x has a value of 26.9 degrees. Now remember that there are, when you're dealing with law of sines, 2 possible answers, so the other one would be 153.1 degrees. However, because of this being 85, we can rule that one out. Now, we still don't have what we need. We need a side, and the angle in the middle. We have this 26.9 degrees, which is this angle down here. So in order to find this angle measure here, we're going to add these two, subtract from 180, and that's going to tell us that this angle has a measure of 68.1 degrees. So now we have our side angle side relationship. So the area of this triangle will equal 1/2 times the side times the side times the sine of the included angle, which is going to be a value of 25.5 centimeters squared. Number 6. Now on this one, you obviously already cannot use your law of sines because you don't have any angle measure, so we will have to start out with a law of cosines. We'll call this angle A here. It doesn't matter which ones you label which. So we'll use our value a squared equals and go ahead and finish our formula. Okay, now let's plug in all of our values into our formula. That gives me 16 squared equals 14 squared plus 6 squared minus 2 times 14 times 6 times the cosine of A. Move the 14 squared and 6 squared over first by subtracting. So 16 squared minus 14 squared minus 6 squared equals this stuff. Then we'll move this over by dividing. So divided by -2 times 14 times 6 just to save a step. Solve that, move the cosine over by doing inverse cosine, and you find out that angle A is equal to 98.2 degrees. So now be careful because that is angle A. Now when I go to find the area over here, this A stands for area. Area is equal to 1/2 times, I do have my side angle side relationship, so it'll be 1/2 times 6 times 14 times the sine of that 98.2, and that's going to give me an area value of 41.6, and that's in square yards. Okay, another way, and we could have actually used it on that one. Another way to find the area of a triangle when you're given all 3 sides. When the measure of all 3 sides of a triangle are given, you can use Heron's formula. And here's an example, or here's the formula for that. Heron's formula is equal to area is the square root of S times S minus A times S minus B times S minus C. All of that under the radical, where S is equal to half of A plus B plus C. So A plus B plus C, that's the perimeter. So S actually stands for the semi-perimeter or the half perimeter. So you add up all the sides and divide by 2. So let's give that a shot. So first off, let's find S. S is half of the perimeter. The perimeter here, add 21, 19, and 18, and that gives you 58. So half of 58, the semi-perimeter here would be 29. So now the area of this triangle, really easy, is the square root of S. Here's the actual formula. Let me write it down. S times S minus A times S minus B times S minus C, to where A, B, and C, again, just like every other problem, are the 3 side lengths. So you have the square root of 29 times. It doesn't matter which one you let A, B, and C. We'll start with this one. Here's A, so we'll do 29 minus 18. 29 minus 21, and 29 minus 19, and that's what you get. Multiply those 3 numbers together, and you get the square root of 25,520. And once you type that square root in, that's going to be approximately 159.7, and that is in square miles, which is much easier again than going through this process when you've got all three sides. You would have got the exact same answer this way. Okay, one more time. A triangular shaped piece of glass has side lengths of 35, 27, and 14. Find the area. Again, using the Heron's formula, since we have all three sides, area is S times S minus A times S minus B times S minus C. So our semi-perimeter is going to be half of the perimeter. So the perimeter here is 35 and 27 is 62 and 14 is 76. Half of 76 is 38. So our semi-perimeter is going to be the square root of 38 times 38 minus 35 times 38 minus 27 times 38 minus 14, which is 24. Multiply those three values together, or those four values, and you get the square root of 30,096. And when you take the square root of 30,096, you get 173.5, and that was in, I believe, inches. Let's go up and make sure. Yes, so that'd be in square inches since you're talking about the area.